I am Dr. PRIYADARSHINI, Associate Professor, Department of Mathematics, Satyabama Institute of Science and Technology, Deemed University, Chennai. Today, I am going to teach you how to do chi-square test. Chi-square test is a very useful tool which is used in many statistical analysis. Chi-square is a test which was developed by a person called Carl Pearson, and the formula is given by sigma O minus E the whole square by E, where O represents the observed frequency, E represents the expected frequency. Chi-square is basically used to test the significance of difference between the observed frequency and the expected frequency. Chi-square has got two major applications, and I am going to discuss problem on these two major applications. The first one is to test the independence of attributes, and the second one is to test the goodness of fit. The test of independence of attribute. What is the meaning of attribute? Attribute means some quality or characteristic. It can be smoking, or it can be drinking, or it can be the IQ level, status, etc. Anything abstract becomes an attribute. So now I am going to explain how to do a problem using this chi-square for the first application, that is the test for independence of attributes. Now the first problem in chi-square test of independence of attributes. First one, find if there is any good association between hair color and eye color. This is the problem that is given to us. We have got two attributes. One attribute is eye color and the next attribute is hair color. And this is the data that is given for us, and we are going to find out if there is any good association between eye color and hair color using chi-square test. Now, when we are solving the chi-square problem, first we have to set the null hypothesis. The null hypothesis is called the hypothesis of no difference. So here the null hypothesis H naught is given as the hair color and eye color are independent. Next, we will set the alternative hypothesis H1. H1 says hair color and eye color are dependent. Then we will go to the level of significance. The level of significance here is 5% level, and it is a two-tailed test. Now we will find out how to find out the expected frequency. Now we will go to the observed frequency, and we will form a table like this in the same manner as it is formed in the observed frequency. In that, coming to the first cell here, we will take the row total into column total, and we will divide it by the grand total for the first cell. Similarly, we will go to the second cell. In the second cell, we will multiply the row total into column total and divide it by the grand total. Like that, we will see for all the cell values and see that finally the grand total matches your observed frequency total. Now the calculated value, as we saw from the table, was 3.6458 given by this formula, which is summation O minus E the whole square by E. Now the degrees of freedom for this test of independence of attribute is given by column minus 1 into row minus 1. So the number of columns is 3. So 3 minus 1 into the number of rows are 3. So 3 minus 1. So 3 minus 1 into 3 minus 1 is 2 into 2, which is equal to 4. So the degrees of freedom is 4 for this particular problem. Therefore, now the calculated chi-square, this we have to check it from the chi-square table, and the value for that is given to be 9.488, and the degrees of freedom is 4 and 5% is the level of significance. So, now the last step, coming to the conclusion, we have to compare the calculated chi-square with the tabulated chi-square. If the calculated chi-square is less than the tabulated chi-square, then we will accept our null hypothesis. Suppose if the calculated chi-square is greater than the tabulated chi-square, we will reject our null hypothesis H naught. The calculated value is less than the tabulated value. Therefore, we will accept the null hypothesis H naught. Now, coming to H naught, what is H naught? What have we set as H naught? H naught, we have said that eye color and hair color are independent. So, we can accept the hypothesis that your hair color and eye color are independent. I will do a problem for chi-square test of goodness of fit. So, the problem says like this: theory predicts the proportion of beans in 4 categories A, B, C, D should be 9:3:3:1, and in an experiment with 1600 beans, the numbers in the 4 groups were 882, 313, 287, 118. So, the question is, does the experimental result support the theory? So, now we are going to do this using chi-square test. Now, the solution is, first we will set the null hypothesis. The null hypothesis is the experimental result support the theory, and H1, which is the alternative hypothesis, is given by the experimental result do not support the theory. Then next we have to write the level of significance. The level of significance is 5% level, 2-tail, and the degrees of freedom for the goodness of it is given by n minus 1. So, because there are 4 observed values, we can write it as 4 minus 1, which is equal to 3. And now we have to find out the expected frequency. Now, the method for finding it is, we have to divide in the ratio 9:3:3:1. So, we get the expected frequencies as 9/16 into 1600, 3/16 into 1600, 3/16 into 1600, and then 1/16 into 1600. So, we get it as 900, 300, 300 and 100. These are the expected frequency. Next, we will go to the calculation of chi-square. So, the chi-square table, the first column we will write the observed frequency which is given in the problem. In the second column, whatever we have found out, the expected frequency, that we will write it in the second column. The next column we will find out O minus E the whole square. Then the last column will be O minus E the whole square by E column, and the total of the last column gives you the calculated value of chi-square. So, for this particular problem, the calculated value of chi-square is 4.726. Now, we have calculated the chi-square value, and that value is 4.726. Next, we have to find out the tabulated chi-square. This can be found out using the chi-square table, and for that we have to find out the number of degrees of freedom. The number of degrees is 3, as I told you earlier, and 5% level of significance. The tabulated value can be found out to be 7.81. Now, the last is the conclusion. Conclusion is, we have to compare the calculated chi-square with the tabulated chi-square. Now, the calculated chi-square is 4.726 and the tabulated chi-square is 7.81, which is clearly less than. So, the calculated chi-square is less than the tabulated chi-square. So, we can conclude that we can accept the null hypothesis H naught, and that is, we can say that the experimental result support the theory. In this video today, I have taught you how to do problems using the two most applications of chi-square, that is chi-square test of goodness of fit and the chi-square test as independence of attributes. In the coming videos, I will present to you some of the other tests like F test, T test, Z test. Thank you.